And if you're just joining us, we'll wait a few more minutes or moments rather, as folks click in, and then we'll dive in. If you're viewing already, good to see you this evening. Good to have you. Go ahead and get settled. We'll begin shortly. All right, as folks continue to join, we will go ahead and dive in. Hi, I'm Julia with Politics and Prose. We're live with author Amy Webb and Greg Easterbrook discussing The Genesis Machine, our quest to rewrite life in the age of synthetic biology. You'll find a link in the chat column to get the book from us at Politics and Prose. If you have a question this evening, go ahead and put those in the Q&A feature found at the bottom of your screen. We'll move to questions in the last portion of the hour, though we apologize in advance if we run short on time. Additionally, if you'd like to enable captions for this evening's discussion, you can click the CC live transcript icon at the bottom of your screen. We do want to thank all of you out there for joining us. We're very grateful to our family of loyal customers who keep our business and spirits afloat. And now to this great new book, The Breakthrough Science of Synthetic Biology and Its Potential for Helping Solve Humanity's Existential Challenges, from climate change to the health and feeding of millions and fighting the next viral outbreak before it becomes a global pandemic. By examining both the science and the ethical, moral, and religious issues surrounding synthetic biology, author Amy Webb provides the background for preventing its misuse by some to re-engineer their bodies and that of their children, further increasing the disturbing division and polarization of societies into the haves and the have-nots. The Genesis Machine contextualizes complex issues, whether to program novel viruses to fight diseases, what genetic privacy will look like, who will own living organisms, how companies should earn revenue from engineered cells, and how to contain a synthetic organism in a lab. Whether we approve or disapprove of synthetic biology, it is coming. We need to understand its promise and peril. Author Amy Webb is the founder of the Future Today Institute, a leading foresight and strategy firm that advises CEOs of the world's most admired companies, three-star admirals and generals, and the senior leadership of central banks and intergovernmental organizations. She's a professor of strategic foresight at NYU's Stern School of Business and a visiting fellow at Oxford University's Said School of Business. She was named by Forbes as one of the 5 women changing the world and was honored as one of the BBC's 100 Women of 2020. She is also the author of The Big Nine, How the Tech Titans and Their Thinking Machines Could Warp Humanity, and The Signals Are Talking, Why Today's Fringe is Tomorrow's Mainstream. You can find both of those titles on our shelves as well as one by moderator Greg Easterbrook here this evening, who is the author of 12 books, including the New York Times bestseller, The Progress Paradox. He's been a staff writer, national correspondent, or contributing editor of The Atlantic for nearly 40 years, and has written for The New Yorker, Science, Wired, Harvard Business Review, Washington Monthly, The New York Times, Wall Street Journal, and the Los Angeles Times. He was a fellow at the Brookings Institution and the Fulbright Foundation, and in 2017 was elected to the American Academy of Arts and Sciences. I think we've heard enough of me spewing all of these accolades. On behalf of Politics and Prose, thank you both so much, and join me in welcoming Amy Webb and Greg Easterbrook. The screen is yours.
I think now my role is to introduce Amy, to ask her to talk about her book and give us the, I suppose, the elevator pitch version of her book, and then she and I will have a conversation, and then we will take lots of questions from the audience at the end. I first have to tell you, Amy, in looking up your very distinguished career, I've read some of your writing in the past in the Wall Street Journal and elsewhere, but I have a personal, I like really impressive titles. And I have to say that your title, Professor of Strategic Foresight at NYU, is one of the most impressive titles I've ever heard. It's such a
It sounds made up.
Well, even if it is, it's worth it. But I'd like to hand it over to you to tell us a little bit about the book, which is out tomorrow or out today?
It's out tomorrow. So this is kind of a little sneak preview.
The Genesis Machine, it's about synthetic biology, the things that could happen now, whether it's all inevitable or whether we should try to stop it. And to me, most most powerfully, you say in the book that soon we may be able to, quote, direct human evolution. So if you could tell our listeners a little bit about what your contentions are.
You got it. Thank you, Greg. Well, first of all, good evening, everyone. I really appreciate your being here. And as always, it's wonderful to be hosted by Politics and Prose. I was there a couple of years ago launching The Big Nine, which is my previous book about the futures of artificial intelligence. And when I'm not launching books at Politics and Prose, I actually hang out there. It's one of my favorite bookshops in the world. And it's just great that there's this incredible community, and they're wonderful stewards of thought and research. Okay, so this is a book about something that you probably have never heard of before, and that is synthetic biology. Before I tell you the sort of central argument of the book, let me give you a little bit of background, because this is a really wonky, strange area of science. So while I was researching my last book and writing my last book called The Big Nine, which is about the futures of AI, I noticed that some of the same people in the field of AI had sort of tiptoed over into the field of biology, which seemed very strange to me at the time. And as I was looking at some of the developments in AI, one of the things that I noticed was that a great promise of AI had to do with speeding up the process of scientific discovery, and also enabling people to do stuff with organic material, living things that we just didn't have the capabilities of doing before. And the more that I started reading academic papers and talking to scientists and learning about all of this, the more it became apparent to me that of all of the emerging technologies in science that I cover as part of my job as a quantitative futurist, this is the one that seems like it's going to be most impactful because of what's on the horizon. So because of that impact, I decided that now was the right time to write a book, because we have to have conversations about this if we're going to ensure that it meets the demands of everybody rather than the desires of just a few. So the book is about a new technology. So again, that's synthetic biology that will eventually allow us to edit, redesign, and create new forms of life. This is going to give us options to deal with existential threats like climate change and novel pathogens, and it's going to improve human longevity. In fact, if you've had one of the messenger RNA vaccines, so in the United States, that's BioNTech or Moderna, you are the recipient of a product of synthetic biology. And as you're about to hear, synthetic biology covers human life, but also agriculture, water, materials. It's about taking organisms and simply tweaking them to give them enhanced capabilities. So there's a lot that's positive here, but as I'm sure you're already thinking, there's a bunch of risk that we really need to be thinking through. And I want to highlight a few areas of those risks. First of all, there's currently no global consensus on how to make decisions that ultimately could benefit or worse, harm us on a planetary scale. And at the moment, there are geopolitical and economic reasons why some countries around the world, which include China and the United States, are to some degree at odds about how to handle and incentivize this new technology. Second, our regulatory frameworks are completely inadequate. And I know that regulation isn't super sexy, but ultimately it's regulation that both enables innovation to happen and ensures that it's happening in a way that benefits everybody. But our regulation in the United States creates a strategic vulnerability because at the moment, there isn't clear guidance on who owns access, who should own the IP, the intellectual property, to certain living organisms. Next, we're drastically underfunded in synthetic biology, but we're drastically underfunded in science and technology writ large at a federal government level. There's really been no consistent government funding for basic research in science and technology. So it's being done in the private sector. And the private sector is fine, except that we need to think through the next order impacts, because today, lawmakers are trying to break up big tech. It would be catastrophic if tomorrow the same lawmakers try to break up big bio. And we're probably going to head into that direction if we're not careful. China is on a quest to become a sort of global biotech superpower, and that's creating tensions with the United States, and that could lead to bio escalation. And on top of all of that, a genetic divide could be inevitable if we're not careful. And that's because everybody seems to trust in science, but everybody trusts in scientists, but not necessarily the science. And what that means is that some people will choose not to engage with these technologies. And that means not everybody's going to have access to the latest tools. And without intervention, society could wind up being genetically cleaved into two: people with enhanced genetic codes and people who never had their genetic codes manipulated, either because they didn't believe in the science, or they were concerned about the science, or they couldn't afford it. The promise of this book is simple and straightforward. If we can just develop our thinking on synthetic biology today, if we can meet each other in the middle and have difficult conversations about what all of this means. What is life? What does it mean to engineer or to re-engineer life? How does that mesh with our spiritual and our religious beliefs? Who should be in charge? What should the transparency look like? How do we regulate it? If we can meet in the middle and have these conversations today in a thoughtful manner, that's going to set us up for success in the future. We'll get closer to solutions for existential challenges like global food insecurity, water shortages, extreme weather events, and plummeting biodiversity. The book is about science, but it's not a science book. It's a book about people. Myself, my co-author, Andrew, we had a lot of struggles trying to start our families. And so part of the story that we tell is the struggles that we went through and how we think in the future, the science that's coming will change all of that. We also talk about the scientists who had to break free from the establishment to invent new technologies, the CEOs who learned very hard lessons about raising too much money too fast, and then having to answer to the market too quickly. We also talk through some scenarios about world leaders, in fact, presidents of a couple of different countries, including former President Donald Trump, whose DNA actually made them a security risk. But this is a book about you. It's a book about life and the decisions that you are going to have to make in your lifetime. Those decisions are going to have consequences. I have to tell you, I'm very concerned about the situation we currently find ourselves in, where, everything is so polarized. There's a lot of people skeptical about COVID vaccines. There are a lot of people angry at the people who are skeptical. There's a lot of misinformation floating around. This stuff is going to look like the olden days by the time that some of these emerging synthetic biology products and processes become scaled, available to everybody. So I'm hoping that people will read this book, because there's a lot of promise. And quite frankly, we're going to need some of this technologies in order to ensure our survivability. And if we wait to have the conversations until too late, we're going to be having those conversations under duress. And that scares me more. That's the real peril of the technology. And that scares me to some degree more than I am sometimes excited about the promise. So I think we can mitigate some of those future challenges in the present, but we got to start now. We can't put it off any longer.
Amy, that seems like a good place to start asking you some specifics about the things you write about in your book. Synthetic biology, making better vaccines or cures for diseases. I think most people would say, yeah, that sounds pretty good to me. If genetic manipulation gets to the point where we could say, turn off the gene that causes cystic fibrosis. There's been some work on that. If it's successful, most people are going to say, yeah, that sounds pretty good to me. If synthetic biology enables us to make crops that grow, you describe a potential future grocery store where the crops are all grown underneath the store using almost no chemicals because they're all genetically manipulated crops. Some people say, well, I don't know, that would be good for nature, I guess. But then you get all the way to the point of, and now let's let Google decide what you're allowed to have in your DNA. And that's, at that point, people get scared. So maybe let's talk a little bit about what do you think it will be practical in the next 20 years and what's a conceptual challenge for farther down the road?
Sure. So let me begin by saying that I'm a pragmatist. I recognize that some of this technology sounds so fantastical that only a techno-optimist or a true utopian thinker would even take any of this stuff seriously. I'm just as skeptical as you are, as you hear some of these stories. In fact, my first career, I've had two careers. My first one, I was a journalist. I spent my entire day, all day long, questioning everybody. So with that in mind, let me tell you a story about cystic fibrosis. So when I was a kid, I was a teenager, I babysat a family, and that family, parents were very, very hardworking. They were both professionals. They were at the top of their game, and they had three kids, and their daughter was born with cystic fibrosis. And I remember the first time going to their house, they were getting ready to go out, and I hadn't seen this before, but they were kind of paddling her really hard on her back. And what I learned is that somebody born with cystic fibrosis requires, I mean, it's a lot. It requires nebulizers, it requires enormous amounts of medication and really tracking the timing of that medication, sucking out the mucus, paddling on the back. And, they were doing their best to provide everything they could for their daughter, knowing that it was highly improbable she was going to live past her mid-20s. I remember her dying. I was older at that point. She was still a teenager. I came home and I went to the funeral, and it was horrible. So my question is, for those of you who are parents, and even those of you who aren't parents, who among us would choose that kind of suffering? Who would choose to endure that if there was a way to prevent it? One of the things that's on the nearer term horizon is something called genetic surgery, which is looking at the embryos before they are implanted using IVF and screening out the embryos that have markers for certain genetic diseases. So Tay-Sachs, for example, is one. There are others. And, so that's screening, but surgery is on the horizon as well. And that would be going in and actually editing out the mutation or the part of the genome that is, that needs to be addressed. It's called genetic surgery. It's not in widespread use. There is a long way to go, but that's something that is definitely on the nearer term horizon. And I think that's really an exciting prospect. Because there's a host of diseases that are heritable that are horrible. And if we can prevent some of that suffering in advance, I think we have a moral obligation at least to give it a shot. Now, to the people who are concerned that maybe this begins us on a slippery slope from which there is little opportunity to return, I would agree with you. I think currently we have guardrails around what can be screened for. So as another example, there's another genetic condition called triple X. So it's basically get an extra X chromosome. And typically that causes not fatal problems in people, but it does cause things like lower IQ, to the extent that you agree that the IQ test is meaningful in any way. Okay, so if that marker is found and you are using genetic screening on embryos, then you can choose to not implant that embryo. It's something you can screen for. What we can't screen for is IQ alone. And there's plenty of good reasons why. but let's say there was a way to run probabilities to see among embryos which had the highest probability of having the highest level of intelligence. Again, as a parent, I think I would want to select, if I had a choice, I would want to select that one. We don't.
Let me interrupt you quickly,
Yes.
maybe to make sure the listeners understand that what you're describing is IVF situations.
Yeah.
You're not saying, well, you go to your doctor, I'm pregnant, doctor, can you tell me what my baby's going to be like?
Right.
We're not at that point yet, although we may be someday. So
we may be someday, and again, I think for the time being, most of what we're talking about is going to require IVF. It's going to require having an embryo outside and being able to screen. Anyhow, we're going to face some tricky questions going forward. Why is it okay to screen for intelligence in one case, but not in the other case where maybe the decision point would have resulted in the same decision for parents and for doctors? So we have some thorny issues we have to work out there. There are some other issues as well. There are opportunities now to edit some of the food that we eat. And in fact, that's starting to be done. This could potentially help mushrooms. If anybody cooks with mushrooms, you look at a mushroom the wrong way and it's brown. I don't care. I will eat brown mushrooms all day long. But if they wind up brown and they're in the grocery store, that becomes food waste. And we have an enormous, inexcusable amount of food waste in this country and in many other countries around the world. So if we could keep fruit and produce fresher simply by flipping on or off a gene, then maybe that's useful because it reduces waste over the long haul. And then maybe even further out, I grew up on the south side of Chicago, and on the south side of Chicago, there's a lot of corn. There's a lot of cornfields. Cornfields take enormous space and lots of resources. And if you've ever grown corn before, you get one stalk and maybe 3 ears of corn, 4 if you're lucky. Well, what if instead we had a stalk of corn that instead of being 6 or 7 feet tall, it was 10 feet tall, it was a little thicker, and it had 20 ears of corn on it and required the same amount of resources? You could drastically improve yield. You could potentially move that field into a warehouse where you could control more of the variables that impact the growth season and the yield. And this is what I'm saying, this isn't Frankenstein, scary science. This is just a different way of approaching how we grow the produce, potentially how we grow the meat that we use to nourish ourselves. In many ways, it's actually better. It turns out to be better for you, better for the environment, but it requires a different mental model.
I think it's worth pointing out that almost all the food that we eat today, plants and animals, has already been selectively bred or crossbred or both to diverge them from nature. When you want stone ground whole wheat, what you're eating is a selectively bred form of dwarf wheat that accomplished some of the things with the wheat plant that you were talking about accomplishing with corn. That's unlike anything that our ancestors could have found 1,000 years ago, and nobody objects to that because it's what they grew up with. But you're describing something that will not be what you grew up with, at least the current generation.
Yeah, and I guess I actually don't write about this in the book, but I'm happy to talk about it publicly. My dad's family had a really difficult time growing up. They were subsistence farmers, not by choice. And I think of the situation we've gotten ourselves in, where somehow we live in a place where food should be abundant, and it is, but not to everybody. So I think one of the promises of this technology is that it gives us optionality. It gives us potentially the ability to grow food in different places, potentially at much more affordable prices, that's closer to the people that need it, and gives them more stability than they do right now. And there's other things. This is not as simple as editing some seeds. There's obviously more that would have to go into it, but it's different. It gives us a different potential path forward, and I would love to see us at least give it a shot.
Many people, obviously, will feel incredibly distrustful of big industry. People don't one of the least popular companies in the world is Monsanto, that makes the chemicals that are sprayed on our foods. even though most of those chemicals have been very carefully engineered to push down environmental impact to the lowest possible level. Still, it's chemicals that are sprayed on foods. People just don't like that. And if you tell them, well, these big companies, they've started altering the genetics of what you eat, but don't worry, nothing will go wrong. There's going to be a lot of public pushback, I would imagine.
I completely agree. And here's what I would say. I would say, if you want to push back, by all means, push back after you've read the label. I don't see huge protests against Cheetos. And I'll be the first to tell you, I love Cheetos. It's a great snack, but it's really bad for you. And if you looked at what you were putting into your body, that's a lot of bad stuff. It's stuff that's not great for your body. But we like Cheetos. I think the challenge comes when faced with what feels unknown. And when we talk about the chemical, Monsanto certainly got in trouble years ago. So, I mean, I don't think we should brush past that. But, the reality is, what are the chemicals being used and how do they create a cumulative effect over time? And do they actually harm you? At the moment, the answer to that seems to be no. But because there's so little that we understand, and there's not a lot, and it's easier to point the finger at a big corporation, we get very upset with Monsanto and nobody gets upset at Cheetos. I'm not suggesting that you get upset with Cheetos, but the point is, a lot of us don't take time to really, again, thoughtfully understand and read through what's actually happening. And to be fair, some people don't have the capacity to do that. I mean, some of this stuff is pretty heady, and we don't do a good enough job explaining in a way that's, removed from politics.
Well, and Monsanto doesn't have funny Super Bowl commercials like Cheetos
They
does.
could.
So, well, they could. But let me just pause to do the obvious and say that the book that we're discussing is The Genesis Machine, out tomorrow. Amy is one of two authors. Your husband is your co-author?
No, very much not. No, that's my friend Andrew. So, my husband is an eye doctor.
Everybody is a good eye doctor. So how did it work out working on a book together with someone else? Was it collaborative, or were you ready to kill each other by the end?
So I'm curious, Greg, have you ever co-written? Have you done a co-authored
book
before?
Never a word. So,
and I didn't have a lot of co-bylines when I was still a reporter. So this was a very different experience for me. And I had sort of carved out a lot of the architecture and done a lot of the research by the time Andrew and I decided to work on it together. And I think what worked out so well, what made us a good team, is that we have very different backgrounds. He's a biologist. He is a capital S scientist. And I am capital C curious in the science. So I think it worked out really well. I asked him a lot of questions. And I think he got excited about exploration, especially in the chapters that were scenarios based. Which sort of read like fiction, although they're not. So I think we worked out well.
Okay. Let me ask you, stop at the moment and say, people are listening, audience members, if you have questions you want to ask, I'm starting to see them show up. Get them in the queue now, because we'll go to Q&A in 10 minutes or so. Question I want to ask you is about the use of synthetic biology as a weapon. When you talk about it as a cure, almost everyone is in favor of cures. What if it becomes a weapon? We can be pleased to say that the track record of bioweapons so far isn't very good. Germ warfare, we should knock on wood, just hasn't killed that many people. But what if there's a form of germ warfare that has horrible effects and it's let loose by the very technology that you're talking about?
Right. So listen, this is a real concern. And let me begin by saying that a fork is dangerous if you stab somebody in the neck with it. So we are surrounded by seemingly innocent technologies that, used in the wrong hands or for the wrong purposes, could be horrific, deadly weapons. Now, I don't mean to be glib, because bioescalation and biosecurity are real risks. I can give you sort of two quick examples. So while I was working on, again, I was just I read like 700 academic papers for this book. It was just, there was a lot. I did one of those things where I should have stopped, and I couldn't. So I compulsively was reading all these papers. One of those papers described a situation where some scientists had, so let me back up. The way that you do some of this work is that you write essentially genetic code, like computer code, in a special software program. So a Word document or a Google document, just typing out code, and sending that code to a place so that it can be synthesized. So you take the sequence, you get it synthesized. The different genetic components are sort of printed out or created for you, and then you get that sample back in the mail so you can do something with it. At the moment, in our kitchen refrigerator, completely in violation of probably every protocol, I've got a little thing of E. coli in a Ziploc bag. Yeah, real bad.
You're not going to invite us over for dinner by any chance, are
everybody
you?
come to our house. I've got E. coli for you. It's for an art project. So it's actually pretty cool. My daughter can take the E. coli, paint with it, culture it, paint with it, put some colors in it, and it'll sort of grow. And then when she wants it to stop growing, she can put resin on it. At any rate, so the process to get the sample back to do something like E. coli art, it turns out was vulnerable, and totally benign code went out, and malware, genetic malware, got injected so that by the time the code came back, it was actually a dangerous pathogen. Now, they stopped it in time, but this is the type of crazy, bizarre, novel attack that I was concerned we may not be prepared for. So I started calling friends. I've got folks in the federal government, Congress. I was calling everybody I know in Washington, D.C. And I was like, hey, here's this crazy paper that I just read. Here's this thing that just happened. Who's in charge? So like, let's say that this God forbid, this actually happens, and it happens at a lab. There's 10 people die, right? And somebody like an FBI field office, somebody comes in and sort of sees what happened. Then what happens next? Which government department is in charge of a bio-cyber attack? And the answer is there isn't one. Nobody knows. So in the event of something like that happening, we're not really prepared to deal with it. And we could be, by thinking this through in advance. I'm a quantitative futurist. Most of what I do is rehearsing the future using data and models and scenarios, but this is the kind of thing that we can rehearse. It's a credible risk. There's another risk that you alluded to, and then I'll stop. So in 2018, there was this research team that was synthesizing. So again, over time, there have been some research teams. There was one in 2002. There was another one in 2018 that have, for various reasons, tried to synthesize different horrific viruses. Smallpox, horsepox. The one in 2002 was Stony Brook, and that was partially DARPA funded. And the point was to see if they could just use off-the-shelf chemicals and publicly available genetic information, DNA, mail order samples, and if they could go through the process to synthesize a horrible virus. And in fact, they did. And they succeeded. And again, the point was to show that if they could do it, it's possible that a terrorist could do the same thing. There are some significant risks that can be mitigated with foresight, guardrails, regulation, and thinking through chains of command. Again, this is partly why we wrote this book, because, it would be horrific. It would be terrible if a couple of years from now, something did happen and we looked back in hindsight and said, this could have been prevented. I don't want to be in it. I would, the whole job of a futurist is to ask what if, so that we never have to ask now what. And that's the thing, like this synthetic biology, this technology does offer us solutions. It's a long road, though. We're in a very, very long time horizon on this. So let's deal with and mitigate the risk now so that we can get on to the solutions. And that we have to be flexible because we're going to find new risks, and some of those solutions aren't going to pan out. So we have to be adaptable and flexible in how we're thinking about all this.
Well, let me raise a question on that. Right now, COVID-19, obviously it's on everyone's mind. It's still unsettled whether it arose naturally or whether it was manipulated. But regardless of how it started, it's similar to other viruses that public health agencies have fought before. We've got a toolkit to use. And more importantly, it's similar to other viruses that our own bodies have fought before. And our own bodies are always the best defense. So suppose synthetic biology enables the creation of an entirely novel organism that nature has never seen. And maybe over the course of geologic time, we could evolve to control it. But that's the kind of stuff that keeps me up at night. How about you?
Yeah, so I guess my short answer to you is yes. And in fact, we've already seen a couple of examples of this. So a preeminent geneticist and his team are working on creating what's called a minimum viable genome. So for basically all of last century, biology and genetics, the whole field was about taking things apart to study them. This century, it's all about starting with the most basic units of life and trying to put things back together or even create new things. So this is Craig Venter, and he's out in California, and I think there's also still a branch office in Maryland. They're working on booting up cells. And in fact, they created one. There's already a cell or a couple of versions of the cell whose parents technically were computers. But it's a teeny little genome. So these are not complex organisms by any stretch. So I don't think anybody should be concerned about giant, monsters that got created in a lab roaming the earth anytime soon. But the monsters don't have to be enormous to be problematic. So I think, again, that's where things like containment and having enough funding, federal government funding to do the types of audits and site checks and that kind of thing, which again is, we're a little bit underfunded. Now, I will say that Venter and Church and all of the people who are working in this space, they are hyper vigilant. I would trust them implicitly, and I know many of them. But they're not the ones that I'm concerned about. What I'm concerned about is lax supervision in places outside of the United States, which for whatever reason, those labs may not be as well attended. Can I tell you one other quick thing about that bacteria? And because it's crazy. Sure. So this is one of my favorite stories in the book. So Venter and his team, they create this organism. It's a bacteria. And one of the things that scientists do when they're tinkering is that they include a sort of digital watermark. So this is adding in extra letters that don't intrinsically change the markup or the nature of the organism, but it's a way of sort of showing this thing is not natural. This has been, there was an intervention. And Venter is kind of a maverick, and for much of his life has sort of shunned authority in different ways. So one of the things that they did was include a quote from the James Joyce estate, which is to live, to err, to triumph, to recreate life out of life. So it's like a really apt, it's from a portrait of the artist as a young man. So it's like a perfect quote if you're going to use a digital watermark. The problem is that the Joyce estate is super litigious, like crazy, insane litigious. And they were ticked off that somebody would appropriate a quote like that. And they were very mad. So they were like, they should have sent us a letter. We should have had written permission. And then here's the problem. Where are you going to send a cease and desist letter? We don't have any law in the United States saying that it's illegal to put copyrighted information inside of a DNA, like inside of a cell. There's no case law against that. So this is actually, as crazy as this sounds, this is one of these weird questions that it would do us well to think through now, because Microsoft has been working on using DNA as a hard drive, as like nature's hard drive, to store things. And then they've already stored a bunch of things inside of DNA, like pictures and texts. And there's reasons to do this. There's a whole wave of technology coming that meshes biology with chips, like computer chips and things like that. And it makes sense. Moore's law is only going to hold for so long. We have to get smaller and smaller. Biology is one way to do that. So there's like this crazy, I don't even understand half of this stuff because this is not my field. But it's really interesting. And what I find, this is sort of like not an existential risk, but it's one of these big risks that is going to come and bite the rear ends of the venture capital folks and the business folks, which is why I want everybody to sort of pause and look at what's happening and think through and do that scenario mapping so that they're prepared.
Well, it certainly sounds like we should be prepared. And one of the things that, as you know, is coming that we alluded to earlier is you can't do this now, but it's not going to be that far into the future when a doctor can say to a woman, well, do you want to choose the skin color of your child? Do you want to choose your child's sexuality? Or would you prefer to leave that to chance and just see what happens? That's coming. And we're going to have to decide in advance how we're going to treat it. And that brings you to the larger question. This is my final question for you, Amy, then we'll take audience questions. Futurism has a mixed track record. Obviously, there are no flying cars. Elon Musk may say we're all going to live on Mars, but it's probably centuries away. How the typical person reading your book, me reading your book, anybody else, and again, the title of the book is The Genesis Machine, just out tomorrow. Excellent book, I can attest from having read it. How do I know how much of this is just crazy futurism and how much of it is going to become genuine?
Yeah, I appreciate that question. And Greg, I feel you. I do. There's a lot of, throughout this past, I was just looking at a ladies' home journal newspaper when it was still a newspaper from like 1899. And it was on it was turn of the century. And it was like 100 ways that this is how the future will look in the next 100 years. And it was crazy. Here's what I can tell you. What I can tell you is that my background, academic background, is economics and game theory. And a lot of what I learned how to do in college and after college was figure out probabilities using data. Now, I'll be the first person to tell you that there is no way to predict the future because the math does not work. And prediction is completely pointless. What would it take for me to predict the exact future of synthetic biology? I would have to have more data than is humanly possible. I'd have to have that data in real time, all the time. I would myself have to be a supercomputer. I would have to be Dr. Manhattan, basically. So there is no way to do this. But what I can tell you is that I'm a damn good reporter. That's where I started. And that's the basis for the work that I do now. So here's the best way to conceptualize and understand change as it's happening. You have to take signals in the present. You have to be sure, because you've got enough data and evidence that those signals are meaningful and that they are worth paying attention to. And then a layperson can sort of think through next order impacts without catastrophizing or getting into conspiracy territory. Somebody like me is going to build models. The scenarios that are in the book are narrative intentionally, because if I presented a model, nobody wants to look at that. So this is a way of rehearsing what might be. The scenarios in the book, the outcomes could be wrong. They might be wrong if we go 10 years into the future, but everything else in the book is correct today. And I think that's what matters most, is that we're paying attention to the signals in the present. I don't do the crazy prognostications and the crazy, I don't know. I'm not so concerned about Mars, to be perfectly honest. Part of what I want us to do is to figure out how to live here, since we're here right now. It doesn't mean that I'm not excited about the future. It means I'm a pragmatist. But yeah, I hear you. It's a criticism that is completely valid. There are people excited about the future, but aren't actually modeling the future, and that becomes a problem. Yeah.
Let me switch to, well, Mars will be there when we're ready, and we're definitely not ready. Let me switch to audience questions, and I'll start with one that's on what you just said, Amy. This question comes from Ruth Schmeil, and I hope I pronounced your name correctly, Ruth. Legislators rarely have the backgrounds and the depth to do effective oversight of science. Who has the fairness and the knowledge to address the kind of questions that concern you?
That's a wonderful question. There are some representatives in Congress right now with great backgrounds in hard sciences. There was a departure from OSTP. Eric Lander resigned, and to be perfectly blunt, that was probably not the best choice going into things. Here's what I would say. What I would say is we have to bet on ourselves. We have to make a long-term bet on our futures, which means that we cannot have a continual cast of characters rotating in and out of key science and tech positions in government, bouncing between the private sector and the public sector, if we don't have a long-term strategy that we're working on. And we just keep kicking the can down the road. So we have to, at some point, make a decision that this is important. We're going to prioritize it. We're going to fund the hell out of it. And we're going to have some type of national office of foresight, strategic foresight, or some office that's in charge of really long-term planning. This is something that the Office of Technology Assessment used to do years ago, and it was defunded. We don't really have anything like that left. So that's what I would say. I'd like to add just one quick thing, and that is, I'm really concerned about how polarized the conversation is regarding anything science or biology at this point related. We have to figure out a way to make room for many voices, even if we disagree with them. I think vaccines are great. I completely understand and recognize that some people are very hesitant about vaccines. I don't think the way to approach that situation is to tell that group of people they're stupid. And I will tell you that it's really hard. It's hard not to hear it that way, the way that we've been talking. So this is challenging stuff. Vaccines are challenging. The stuff that's in this book, which is not made up, it's coming. This is going to challenge some people's beliefs, what they hold to be true ethically and morally and spiritually. Science and religion are not necessarily incongruous. So we're going to have to figure out a way to make space for a broad diversity of thought and approach people with curiosity rather than condemnation. And unfortunately, I'm not observing that happening at all right now. And maybe that's a leadership issue. Maybe we can ask our elected officials to give us some help by stop being so vitriolic. But I recognize that this is an election year, so probably that's not going to happen.
Right, that's what our elected officials are a lot more frightening than scientists are. Let me ask you another question from the audience. This one comes from Jean-Paul Marie Justine. In 8 years, the entire baby boom will be at least 65 years old. That's 72 million people. Amy, you've been talking mainly about the effects on the very young, right down to the IVF stage. Won't synthetic biology and its ability to prolong life be focused on the very old, and how will that affect society?
So let me answer that. I don't have data yet on which groups become the most prized or targeted as some of these technologies become available. I can tell you that the people with the money are on the older end of that spectrum and probably more willing to test, to fund, to investigate some of these technologies. My dad, I talk about my parents in the book. My dad had a hypertensive issue when he was very young, and it's just never gone away. He's on one medication to deal with that and he had been for years, and that caused long-term impacts on a bunch of other things. He's like taken 17 different medications at once. This is the kind of thing that sometime in the next 10 years might be able to help him to some degree. My mother died young of something called neuroendocrine cancer, which is, I don't know, we tend to name cancers after the body parts that they affect rather than anything else. So in her case, it affected her endocrine system and located at the pancreas, but she didn't have pancreatic cancer. Anyhow, what this meant was that she was on chemotherapy treating the pancreas and the endocrine system, but really neither were designed for her. And that was the best that anybody could do. And she was seen by specialists at some of the best hospitals. I look at a future in which there might be a way to engineer something, a virus even, that, a virus is just a receptacle for code. That's all it really is. And you can go online and look and see what a virus looks like. They're crazy looking. They look like little code receptacles. Maybe there's a way, 10 years from now where we have some different approaches to cancer. And one of the things, part of the reason why we got to vaccines so quickly is because Moderna and BioNTech were working on messenger RNA for cancer. So this is a super long-winded answer. My point is, I don't think this is just technology for the not yet born. We're going to see different applications of this in many different permutations going forward over the next, several decades.
All right. Let me ask this question. This comes from an anonymous member of our audience. Is there already a significant synthetic biology technology that could be implemented right now or in the near future that's being held back because of religious or ethical objections?
That's a great question. I would say that there was a lot of back and forth during the Trump administration around banked stem cells and whether or not stem cells could be used and under what circumstances. And that just really messes the research community up. It takes a really long time to write grant proposals and to get in pole position to get funding. And some of those people had their funding yanked from them because of this sort of back and forth. I think we need to, again, Francis Collins, who's a former, come on, Amy's brain that's melting right now, NIH director. Yes. Francis Collins is very religious. He has written several books, and he's also made public comments about why it's important to use the stem cells that we had that were currently banked. This is going to be a hard debate to resolve in this country because we have differing opinions and viewpoints on at when life begins, at what point. I will tell you, however, that this is not going to be a problem in other countries like China, which have vastly different ideas about when life begins. It is not at conception there. And therefore, how, when, where, under what circumstances, embryos, stem cells can be used. I think we're going to need to figure out a way to resolve our internal tensions in the United States on this issue, because at some point, without a resolution, it makes us really strategically disadvantaged. It puts us at a national strategic disadvantage. And I'm not saying that country should come before personal beliefs, but I do think we need to really evaluate our personal beliefs, at least with an open mind. And if you get to the same place at the end, fine, but don't start from a place of no. Start from a place of, let me think through this.
Francis Collins, but if you other members of the audience don't know, a very fine man in my estimation. As a researcher, he did his youthful work in trying to locate the cystic fibrosis gene, the very thing that we were talking about and hoping will someday that disease will become curable. We haven't really talked much about the environment. So I'd like to close with, we'll have one more question. This is from our audience member, Stephen Lonker, and he asked this question. Suppose it's possible to genetically modify DNA of things that we put into the environment using synthetic biology for the purpose, for our original purpose of protecting or improving the environment. They'll start to reproduce, they'll start to mutate on their own. Don't we run the risk that they will cause more significant problems than what we were trying to solve?
Thank you for that question. So what you're describing is something called outcrossing, and that's where you want you have something that was engineered and it sort of takes off on its own. We have a version of that in kudzu, although kudzu is a total dual use technology. Kudzu was brought here, I think, after the Dust Bowl as a way of helping to regreen parts of the country so that didn't happen again. And now you drive anywhere on the 95 corridor on the East Coast, and it looks like a giant green monster has taken over the trees on the side of the road. Again, we're not there yet, but it's plausible that there would be off switch. There could be off switches, and it would be potentially possible to sort of stop certain things from growing. I think that's in the farther future. Here's why I am not as concerned about that right now, and instead much more optimistic about what this technology holds. And that's because of what happened at COP26. So at the most recent climate talks, I think I was one of the only people in my circles that was completely unsurprised by the fact that the UN climate talks ended without everybody agreeing and without a comprehensive, super aggressive plan. It's absolutely not in China's best interest economically to reduce its dependency on the things like the factories and the coal that produce the excess CO2. Likewise, in India, it's not in their best economic interests, and nobody's giving them an alternative. And at the same point, we're all still relying very much on China and India for a lot of our manufacturing. So if you look at it from that point of view, which I didn't hear a lot of people doing, like, what choice do they have? China is about to have the upward social mobility at a scale never seen before in human history. They have 1 billion people to feed. They need to have water for 1 billion people. So without any other option, there's no way that they're going to agree to drastically reducing CO2 emissions. They can't afford to. So if we, and I don't mean to sound fatalistic, but if we accept the fact that it's improbable that our governments are going to align on the hyper aggressive tactics that would be awesome, but are unlikely to mitigate the current CO2 issue that we've got, then let's instead reframe the conversation. Let's use reperception. Let's think of that CO2 as a feedstock. And if we have an engineered leaf that would suck out the leaves are sucking out CO2 anyways, but let's engineer it so that it sucks out and can hold 100x the amount that it would normally hold. And on the other side, the leaf would excrete nutrients, which is what they do right now, right? But let's engineer something that sort of makes that happen super fast and at super scale. Well, that actually potentially makes a dent. Doesn't totally solve, but it makes a dent in that CO2 problem. The other thing potentially that it does is it helps us with our current topsoil problem, because we've got a massive issue with our topsoil not having enough nutrients to feed the insects and the animals and the bugs and everything else that rely on it. Again, this is a very different mental model. And this is what the point of the book is. It's asking you to at least confront your cherished beliefs and think through, and to reperceive ways that we could live that help preserve ourselves and help us deal with some of the challenges that we've created.
And that's a great way to end, Amy. Forcing you to confront what you already believe is one of the highest goals of literature. And your book does that. Politics in Prose does that every day. We thank Politics in Prose for hosting this session. And I think we're over and out at this point.
Yeah, we here at Politics in Prose, of course, just want to double our thanks to author Amy Webb and Greg Easterbrook. What a great and fascinating conversation. And you answered one of my climate change questions, Amy. I'm so going to dream about this beautiful leaf sucking all this CO2 out of the atmosphere. What a beautiful image. To our attendees, if you want to purchase this great book, the link is in the chat column, find it there, or you can visit us at politics-prose.com. While you're there, feel free to check out our events calendar for everything else coming your way. And until we meet again, we hope you are out there staying strong, staying safe, and of course, staying well read. We will see you next time. And our thanks again to author Amy Webb and Greg